What now?
Got it.
Sweet. Alrighty, let's do a little quick recap of where we have been at. We talked about basic procedural programming, which includes variable assignments, both declarations and definitions, control flow, which is all your like if-else statements. There's also other versions of this called like switch statements and case statements, but they're all basically variants of if-else. Loops, we talked about like procedural looping, both for loops and while loops. Those are most of it. There are these other things in other languages called iterators, but they're all basic variants of like while and for loops. And then we talked about functions. Your basic functions like subtract, add. How your inputs are these arguments that go in, and your outputs are what's there. We talked about what's next to the return statement. We talked about how this is the name of the function and what you use to call the function. For example, this is add, and if you want to call the function in your code, you type the name of the function, whatever you want to be the inputs, and whatever you assign it to will be the output. We talked about fancy functions, how basically you have like the ability to use other functions within functions to do really fancy stuff. I quickly wrote a couple examples this morning of even fancier functions. So here's a fancy function that's got like, addition, subtraction, and then if else statements. And different things will print depending on kind of how the inputs work out. Here's an incredibly fancy function that has a while loop and an if else statement in it, plus a break statement. Basically what happens here is you have A and B going in. It will loop forever because it's true. So you're relying on this break statement to stop it. It checks each time through the loop if A is greater than B. And if A is greater than B, it prints break and then it stops the function. Otherwise, you have an else statement here that prints out this text and then increments A each time. Basically, it'll run until A is greater than B. And so you have all kinds of different fancy functions that you can do. Now let's get into object-oriented programming, which I think is what a lot of you guys want to talk about. So object-oriented programming is a way to combine functions, procedural programming, and variables all together inside of this thing called a class. How many of you guys have ever done anything with object-oriented programming before?
I've done a little bit, but
Okay.
it always confuses me. So this will be good.
Sweet. So a class is similar to a function in that it's a template. Okay. So you have to call the class by like instantiating the class. We'll talk about that, but it's just a template to start. So there used to be, it exists to reuse codes over and over and over again. So we're going to do the classic examples of an animal class. And in Python, it's just class and then the name of the animal. We're going to give it a couple things. We're going to give it a couple variables. I need to quickly look up something because I'm trying to remember if you have to use the self keyword in Python. Python's.
You do. For what?
You do? For self dot equal. Okay. I thought you
Yeah.
did. Self dot sound equals text. We're going to do some text of a generic animal sound. And then we'll do self dot. I'll explain all this in a second. Number of legs equals, and we'll just do 0 for unknown. It's like not defined yet, but you can't do undefined in Python. So we're just going to say 0. And then we're going to do a couple. So those are the variables inside the class. And what that means is that every time this class is used or instantiated, just like a function, those variables get defined when you instantiate the class, when you use the class. And so this particular class is semantically an animal. So I've given the animal a sound and a number of, I meant to say legs. Now, the next thing I'm going to do is add a couple of functions that are templates in this class. And we call these functions, these are, I'm going to, by the way, comment this. These are variables, but within a class, we call them members of the class. And then this next part will be functions, but functions within a class are called methods. Okay. So the next thing we're going to do is we're going to define some methods in the class, and we are going to define a make sound method. You have to use a keyword in here, self. And all this is going to do is this is going to print out the self.sound variable. Jason, can you QC me? Is that how you do that in Python? Is it self.sound within the class?
Yeah.
It's been a while since I've done this. Okay, so make legs, or I mean, get number of legs. Self. And then we are going to print self dot legs, or a number of legs. Oop. Yeah. Sorry. Number of, come on, of legs. All right, so that's our class. Now we're going to go outside of the class and we're going to instantiate the class. And the way we're going to do that is we're going to name a variable. We're going to name it my animal object. I'll explain that name in a second. Is equal to, let's see my syntax here. Yeah, is equal to animal called almost like a function. So what this is my animal object is the object which is instantiated off of the animal class. So what this means is that similar to how you call a function, we are now calling the class. But we don't just say call a function. We actually say, like, I want you to instantiate the template of the class into a real thing in memory. And so this right here calls what's called a constructor to construct the class. In certain languages, like C++, for instance, you have to write the constructor yourself. In Python, you don't. It's actually kind of like implicit. And you can actually use constructors to pass in additional data. For example, I could say like A, B, C, D, similar to a function. And that data would end up, I think you can actually override in Python, but I could build a constructor manually in Python. And I could say like construct yourself, and I could say like A, B, D, and I could pass those into the constructor, similar to how a function, and then within the function, I could say like self.sound equals A. Like I can kind of preset some of the variables within the class using a constructor. I'm going to not do that right now. That's a side tangent. I'm just going to generically instantiate the class with my object and assign it to the variable, my animal object. That variable, we call it an object when it's instantiated from a class. How you use it then, like what's the point of this, is you can now call those functions and variables from that object within the class. So if I want to say like, a new variable out here, we'll just call it sound variable equals my animal object, I can now say dot, and it prompts me, and I can say make sound, and basically call the function within the class from the object. And then if I print sound var, it should print out. Clearly a mistake was made. Self.sound equals generic animal sound. Self is not defined. I don't think it's actually self.
You might not need it outside of yeah,
I might not need it unless I'm calling it separately.
unless you
Yeah.
put in like the constructor or something. Yeah.
Every language is a little different. Yeah, so I didn't
There
need
we
it
go.
here. Actually, let me comment out everything else, just so that there's nothing else on the screen here.
So
Um,
this self idea is what always throws me for a loop. So
yeah, we'll talk about that. Why am I printing today? Oh, I'm printing. Yeah, that's it. I don't need to do that. I'm going to return instead of print this thing, and I'll talk about self here. So self is every object that you create, Justin, is separate. So each instance of the class is separate. So this self keyword is a way for the language to know what it is referring to. So within this class right here, if I don't have the self keyword here, it's going to throw an error because it's going to say, what is sound? It's going to think that I'm trying to call sound within the context of the whole file, not within the context of the class. The self keyword tells me, look within the context of the class for the variable. And if I've defined it within the context of the class, the scope of the class, then it will go find it. Does that make sense why the self keyword is needed for this line?
yeah, so I guess what always throws me for a loop is like this animal class. It seems to me like can only make a generic animal sound. Your make sound is now a generic animal sound for every animal.
Correct.
Like
Correct.
Cameo is like object oriented as well. So if I were to make an animal class like a block in Cameo and I were to create instantiations of that animal, I could create like a zebra and a bear and a dog. And then where for the sound, it would be like just kind of blank and I could instantiate, the cow goes moo.
Yep. So what you're dealing with is called inheritance, and we're about to start that. There's a reason I did the animal to start, because we're going to talk about doing a cat class and a dog class. Before I get there, does this make sense to Rachel? What questions do you have?
I'm following Ish.
Okay.
And Justin, his use of 0 and generic animal sound is analogous to using default value.
Okay.
Yeah. Yeah, these are just generic default values. Now, in computer science programming here, if I don't ever change them, they're never going to be anything different. I could use this object and I could say I can actually access that variable in this object and say my animal object dot sound equals like bark. Need to rotate these two. And then I changed it. So now if I print it, it says
Oh, I
bark.
see. You've changed it for my
I
animal
changed it
object. So my animal
directly.
object could be dog now.
Correctly. Correct.
Yeah.
But if I were to remake animal down here, and I may get my animal object too, right? And then I do the exact same situation here. I'll just be clean about it. Bar 2, right?
Mhm.
It is now going to say, hold on. I didn't do this correctly. It's my animal object too. There we go. It's going to say bark and then generic animal sound. Because the first object we changed to bark, the second one we did, right?
Got it.
This is actually really bad practice in computer science. We don't like to do this, direct access a variable directly. And so there's in other languages, not Python, but other languages, you actually restrict the access of the variables with these keywords called private, protected, and public. So you want to restrict certain functions or variables so that you can't access them outside of the class. And so you're enforcing using a function to access something like get number of legs. Functions always start with an action because you're doing something. So like, I want you to get me the number of legs. And then like in C++, like I might make these not accessible. So this would fail, but I could do this, like make sound or get number of legs. I could also do a setter where I say set number of legs. And the reason I might have getters and setters functions to set those variables rather than changing the variable directly is because within the functions, I might have additional checks. Like I might never want a variable to be set to a number above 10. So if someone tries it, I won't let them. I'll throw an error, and that's how you can kind of enforce things within classes to obey certain state changes within the variables. Rachel, does this make sense before I go into inheritance? Because this is not inheritance, just to be clear. This is just single class object oriented. This is very confusing the first time you see it. So I'm happy to sit here and explain it. We have some time here.
I was muted. I think that makes sense.
Okay.
So
now,
still
Justin,
analogous to Cameo. So it's,
Yep.
it's not
Right.
bad.
Yeah, so you have like default values, and then you have like
Yep.
operations.
Yep.
And then he created 2 instances.
Sure.
now let's talk
Right.
about inheritance, which I'm going to do right here. So that was just generic object-oriented programming. You can have as many functions, as many variables as you want, do as many constraints as you want. In other languages, you can restrict which functions and variables are accessible outside of the class. And so if they're not accessible outside of the class, you have to use them somewhere else in the class through a function that's public that someone else can access. Okay, now let's move to inheritance and abstraction. So inheritance is a way to create another class that inherits all the attributes of the parent class. Our parent class in this case is going to be animal, but our child class is going to be dog. You usually capitalize the first letter of the class, just FYI. And this is how you do inheritance in Python. So I have now inherited my class, right? I've done nothing else, but I've inherited my class. What does that mean? That means that for the purposes of this class, all of these members and functions are now within this class. Now I could call it good there, and I could do my dog object equals dog, right? Now the variable 3, my dog object. Check. Let's do dog sound. Dog sound. Dog sound. So am I missing here? Do I have to add something to it? I'm guessing. Oh, expected indent block. So I have to add something. We're just going to add a generic like def blah function that does nothing but returns 0 to feel that it's different. I think Python's freaking out because it's not any difference. Def. Return, not return equals, return 0. Okay, now this should work. Okay, so let me get rid of the other print statement just for clarity here. Oh my gosh, what's happening? Go in here. Okay, so this dog printed generic animal sound because dog inherited all of this stuff, right? But I added an extra function into dog that was blah. Now, what do dogs like to do? Let's say dogs like to lick, right? So I'm going to add a lick function. And I'm going to say return, and I'm going to add some new variable. That's going to be lick equals lick. And I'm going to return self.lick so that it knows to return this variable within the context of the function. And so now I can print, let's say my dog object dot lick, like that. And it returns, what did I do here? No, I need to assign it to a variable. Oh, I didn't. I'm just going to assign it to a variable. Found the method dog lick object. Returning the object, not the Any idea what's going on here, Jason? I have lick set to a variable.
Let me watch. What are you doing?
I have lick set to a variable here, and then I have
Yeah.
a function called lick. Oh, it's because it's a function.
Yeah.
I'm going to say get lick.
I
Just
should notice
it was
that.
a name deconfliction issue.
That's good to know.
There we
I
go.
actually didn't know it did that by default.
There we go. So now it's printing lick. So it prints lick, but if I tried to have an animal object print lick, it would fail. Like if I said animal object dot get lick, it's not even like prompting because it's not a thing, and I'm just going to get like an error. Because
So-
animal does not have lick, but dog has lick.
So one of the biggest differences that I'm noticing, I just want to confirm, is when using a class and defining functions, one of the things that makes it different than just generic scripting where you're defining functions is you have access to every variable that you define in the class without having to pass them as inputs. Is that correct?
That is
You can just-
that is correct.
Okay. And that's probably
It
one
is a way of combining your
right?
data and your action together. And so, like for it build the characteristics of whatever semantic thing you're doing. So dog licks. I need to also do a couple of things like def set legs, and I'm going to do self. Quick and close in here. So we're going to set the legs. Self. I have to send self into the function. That's a Python thing, but I'm going to add a argument to this function that is num of legs. Num of legs.
This would mean like you could call this outside of the class. So it's like
Yep.
user input at this point.
Self dot legs.
Got it.
All right. Self dot legs. Is it? It might be number of legs. I don't know why I named it. Yeah, I named it number of legs equals 4. Right. And then I also, because it's a dog class, so I can add this. This is important. I can add this setter up here. Number of legs. We'll just say equals number of legs, right? I might want to be able to change the number of legs for anything up in the actual parent class. And I might want to be able to set the sound as well. What we're going to do. It's very common to have getters and setters. That's what they're called. So set sound. And then I'm going to say sound. And then I'm going to say sound. And then I'm going to say sound. So now I have the ability to change the sound outside of the class, right? And I'll just get rid of that. All right. So I've added a function, and I've done the ability to set different things. So what I'm going to do down here is, because this is a dog, right? I'm going to do this. I'm going to say my dog object. So my dog object dot set legs as 4, and do my dog object set sound as bark, and then I'm going to do print this below that down here. And now it barks instead of as a generic sound. So I have now changed the value of the function. The thing that object-oriented programming is built for is actually something called polymorphism. So there's inheritance, abstraction, polymorphism, and there's one more term. I'm trying to remember what it is, but so those are the key principles. Inheritance inherits all the stuff from the parent class into the child class. Abstraction allows you to build abstract interfaces that are just generic characteristics that you can then inherit later. So abstraction and inheritance are very connected. And then there's polymorphism, which is what you're probably interested in, Justin, which is kind of at the heart of object-oriented programming. So I'm going to come up with a polymorphic function right now. I am going to override this function called make sound in my dog class by doing this. def make sound, return super bark. Now, what has happened here is that within this class, even though it inherited make sound from the parent class, because I rewrote it in this class, it now overrides whatever was in the parent class with what is here. And so now it will do super bark instead of whatever else it was doing. And I'm going to get rid of that. Now it super barks. Okay. But that's
So this is just redefining in Cameo. So Cameo just copied this.
Yep.
Yeah, got it.
override. And then there's overload. Those are two different things. So override is this. Overload is this, where I add an extra argument. Noise. So now I have two make sound functions in the same class, but they have a different number of arguments. So they're actually different functions. And so what I will do here is my dog object dot make sound. This would call the regular make sound super bark. This one, if I add an argument in here of some type that says like, super, super, super bark, and then print dog sound. Or print it's dog sound. Now I will get super bark, super, super, super bark. So overriding with this function, overloading with this. And so what you do is you typically in object-oriented programming is you will make a generic interface class of whatever you want, generic characteristics. Then you will build tons of child classes of different layers. So I might have like an animal. Then I might have like a cat and a dog. Then I might have like in the cat side, I might have a calico and a sphinx and like all these other cats. And then for a dog, I might have, a dog class, change it all to bark. And then I might have like terrier, bulldog, French bulldog, like all these different characteristics of subclasses so that I'm reusing code all the way up to the top, but I'm overloading and overriding the functions as I go to facilitate like more and more specific object-oriented programming to build a full architecture. Does that make sense? We got like 1 minute left.
Yeah, that was awesome. That's the best I've had it explained, and it makes a lot of sense.
Awesome.
It's not
Rachel?
that far off from Cameo. Like there's
Yep.
similarities, so I can grasp it.
So everything else in computer science that is not command languages or these other weird paradigms is like, variables, procedural, control flow with control flow and for loops and then while loops, if else statements, object-oriented programming. And that's most of computer science. Everything else becomes more specific nuances that like languages give you. Like there's 4 types of polymorphism. I showed you one here. There's also a paradigm called aspect-oriented and a few different things, but like 90% of it you guys have seen here now.